Let's take a look at section 1.5, rewriting equations and formulas. So we start with some common formulas. You may know, you may not know. D is equal to RT. D stands for distance. So you take your rate times time. Frequently if we're talking about driving, if you're going at 65 miles an hour for 5 hours, that'll tell you the distance that you traveled. Okay. Money is a very popular topic. To find simple interest, the formula is capital P times R times T. The capital I is the amount of interest that you've earned. The capital P is the amount of money in the account. It's called the principal. And R is the interest rate, and T is the amount of time. Okay. And then converting between Fahrenheit and Celsius, Celsius and Fahrenheit. Bonus points if you can spell Fahrenheit correctly without looking it up. Our formula here to get the Fahrenheit temperature, if we know what the temperature is in Celsius, we take 9/5 multiply it by the Celsius temperature and then add 32. Well, that's again in degrees. Going back to, I guess for all of you, just to last year, but yeah, some of this was last year, some of it you knew a long time ago. To find the perimeter of a rectangle. Now, I'm going to use the formulas here where we use the variables L and W for length and width. So the perimeter, let's see, there are a couple of different ways we could do this. 2 times L plus 2 times W. For the area formula, you multiply length times width. For area of a triangle, you simply add together the lengths of all of the sides. If it just says triangle, well, A plus B plus C. Meh. For a rectangle, you have to have two sides that are the same called length, and you're going to have two sides that are the same called width. So our formulas here for rectangle can be a little bit more specific than our formulas for perimeter of a triangle. Area of a triangle, we have to take 1/2 times the base times the height. And again, base and height have to be two segments that are perpendicular. For a trapezoid, this one's a little tricky. We're going to take 1/2 times the height of the trapezoid times the sum of the two bases. And again, for a trapezoid, you're going to have two sides that are parallel. Those are called the bases. So this is base 1, this could be base 2. And then we need to find that perpendicular distance for the height. For circumference of a circle, we could do pi times the diameter, or 2 pi r. Now again, diameter is only first power, radius is only first power, circumference is a measure of the distance around the circle, distance is only one dimension, don't get it confused with area. Pi r squared, where we take radius times radius, because area is two dimensions. Okay, so those are some formulas with which you should be familiar. As if they didn't spoil it, example number one here, they tell you circumference is equal to 2 pi r, and they ask you to solve that equation for r. Well, all right, so understand what the directions mean. We have, remember, pi is not a variable, pi is a specific number. So we have two different variables here. We have c for circumference, and we have r for radius. When they ask you to solve an equation for a particular variable, we have to use order of operations. We need to get that variable on one side of that formula all by itself. So if we start with circumference is 2 times pi times r, and we're going to get r all by itself, what we need to do here is divide by 2 and divide by pi. What you do to one side of a formula, you do to the other. So we can say the radius is equal to circumference divided by 2 pi. With example number 2, now that we've done that, find the radius of a circular pool if the circumference is 26 meters. So again, we have a formula here that tells us what the radius has to be. So we're then going to substitute 26 in place of what we have for circumference. So it becomes 26 over, I'm sorry, I shouldn't be writing in green, I'm not finished yet. 26 divided by 2 pi. And then we can reduce the 26 divided by 2 is 13. 2 divided by 2 is 1. So we have 13 divided by pi. Now it'd be nice if we could come up with a decimal approximation of that. So 14.13. Now they didn't tell us exactly how far out to go there. If you want to put 4.1 meters, that would be perfectly fine. All right, let's try example number 3. And there's a couple of different methods that you could use here going through this. Find the value of the variable y in the equation 3x plus 4y equals 8 when x is equal to negative 4, and find the value of y when x is equal to 12. Well, we could substitute and simplify, okay? So when x is equal to 4, this starts off as 3x plus 4y is equal to 8. So we'll take out the x, we'll put in negative 4 in its place, and it's still equal to 8. Simplify 3 times negative 4, that should give us negative 12, still equal to 8. But then we would have to add 12 to both sides. So we'll get 4y is equal to 20. Then we'll do a little bit of division here. We'll divide both sides by 4. 20 divided by 4, y is equal to 5. So again, substitute and then just use our order of operations. Now, another way we could do this here, if we're going to have to put in negative 4 for x, and then put in positive 12, and maybe put in more and more and more, maybe we should come down here and solve for what y equals first, and then the substitution might be faster, it might be easier, okay? So if we're going to solve for y, we want to get that y term by itself. So we'll have to subtract 3x from both sides. So we get 4y is equal to negative 3x plus 8. But then again, I want y all by itself. I don't want to know what 4y is. I want y by itself. So now I'm going to divide by 4. which means I have to divide this by 4, which means I've got to divide that by 4. I have to divide everything, not just some things, not when it's just convenient, not when it turns out to be a whole number, everything. So I get y is equal to negative 3 fourths x plus 2. So now it's a matter of when I want to know what the value is for negative 4. I'll put in negative 3 fourths times negative 4 and add 2. Well, negative times a negative is positive. 3 fourths times negative 4 should give me positive 3. 3 plus 2 is 5. And then we can do the same thing with the 12. We could substitute it first. Or we want to take negative 3 fourths times 12 plus 2. Well, negative times a positive, that'll be negative. 1 fourth of 12 is 3. 3 times 3 is 9. So that's negative 9. Negative 9 plus 2 gives us negative 7. Okay. So here, same answers. Here, same answers. Two different ways to do it here. Okay. I would suggest that if you're supposed to solve for this equation is two variables, solve for one of them when they give you a value for one, and it's just one equation, use method one. That's the easier, straightforward way. If you have to find this for when x is this and x is this and with several different things, then method two is in the end going to save you some work. Okay, and again, I know that idea, save you some work, that's a good thing. All right, so I'd like for you to do the checkpoint here. We're going to put this, I'm going to let you have, say, the next 5 minutes. Answer those for yourself. All right, well, there's only two of them. Let's say 4 minutes. Ready, go. Okay, let's see how you did here. All right, so you're asked to first of all take the formula where perimeter is equal to 2 times the length plus 2 times the width and solve it for W. So that means subtracting 2 times the length from both sides. So 2W is equal to P minus 2L. And then we'll have to go ahead and divide everything by 2. So if you just want to leave it as one fraction here, where the width is equal to P minus 2L all over 2. Then find the width of the rectangle. So again, that's why we solved it for W. If the length is 9 meters, so that we'll put in 9 in place of the length, and 32, we'll put that in place of the perimeter, and we'll solve it from there. So 32 minus 2 times 9 will be 18. Yay, they're all nice whole numbers, so we'll know this divides out evenly. 32 minus 18 should give you 14. 14 divided by 2 is 7. So that should be 7 meters. Careful, make sure that you put a unit of measurement on there. For number 2, find the value of y in the equation 5x minus 4y is equal to 9 when x is negative 3 and x is 9. So again, let's do the method 2 here. So the first thing I'm going to do is subtract 5x from both sides of the equation. I'm going to come over here and write it. So negative 4y is equal to 9 minus 5x. And then I need to divide everything here by negative 4, and here by negative 4, and here by negative 4. Absolutely everything. So I get y is equal to negative 9/4 plus, again, I got negative divided by a negative, 5x over 4. So now, when x is negative 3, we can say y is equal to negative 9/4 plus 5 times negative 3 over 4. Now again, just leaving them, it didn't divide out and simplify, and that's a good thing in this case because we get common denominators right away. So this will be negative 9/4. 5 times negative 3 should be negative 15. Negative 9/4 and negative 15/4 should give us negative 24/4, which we should then simplify into negative 6. And then do it again. Y is equal to negative 9/4 plus 5 times 9/4. So negative 9/4 plus 5 times 9 is 45. So if we take 45 basically and subtract 9, we want to go that way. That'll give us positive 36/4. And again, that reduces down, so we should get positive 9. All right, and for the last one here, converting it from English into math. Sam is buying some 41-cent stamps and some 58-cent stamps. Write an equation with more than one variable to represent the total cost of the stamps. And then we can answer the question, 12 of these and 10 of those is how much? All right, so if T is going to be our total cost, we're going to take cost times the number of 41-cent stamps, and then we have to add the cost times the number of 58-cent stamps. So evidently they want us to put X as the number of 41-cent stamps, and we're going to put Y as the number of 58-cent stamps. So for our algebraic model here, T is equal to 0.41 times X plus 0.58 times Y. So again, this should be our lovely equation to use. Then we can go ahead and do some basic substitution. They tell us up top that he wants to buy 12 41-cent stamps. So we'll take 12 and substitute it there. And 10 58-cent stamps. So we'll put in 10 in place there. Okay, so 0.41 times 12 stamps. I wish they gave me more room to write here. That's $4.92. And, well, hey, look at that. Multiplying by 10. Don't even need a calculator for that. That's $5.80. So that's a total of $10.72. And that pretty much wraps it up here for section 5. If you would please then log on to your account there with Delta Math, you should find an assignment waiting for you with problems of these types. And hopefully you can work productively and get all of that finished before class is over today. Good luck.